Hey everyone, and welcome. Today, we're going to crack the code on something that trips up pretty much everyone at some point, Python expressions. We're going to see how a little hidden rulebook basically controls everything your code does. Let's get into it. So picture this. You're writing what seems like a really simple line of code. Just doing some basic math. It looks totally logical, totally fine, but the result that Python gives you back is just not what you expected at all. We've got ourselves a little math mystery to solve. And here it is. This is our culprit. If you just read this left to right, your brain probably goes, okay, 10 plus 3 is 13, and 13 times 4, that's 52, right? Makes sense. But Python will tell you with 100% confidence the answer is 22. So, what is going on here? Well, the key to solving this whole puzzle lies in understanding one of the most fundamental building blocks of programming, and that is the expression. Think of it like learning the grammar of Python. Once we get this down, everything else starts to click into place. So, what even is an expression? Well, here's the textbook definition, but let's break it down. The operators are just the symbols, like plus, minus, times. The operands are the actual values they work on. The numbers, like 10, 3, and 4. You put them together and you've got an expression that Python has to figure out to give you one single final value. Okay, but it's not quite that simple because not all expressions are created equal. To really get to the bottom of our mystery, we need to know the different flavors of expressions that Python works with, because it turns out they all play by the same hidden set of rules. First, and most importantly for our case, we have arithmetic expressions. These are probably the ones you'll use the most. They just take numbers and use those math operators to crunch them down into a brand new number. Simple as that. And here are the tools of the trade. You'll recognize almost all of these from school, right? Addition, subtraction, multiplication, division. Python also has exponentiation. That's the double star for doing powers. Our little mystery uses just two of these, the plus and the star for multiplication. But it's not all just about doing math. Expressions can also be used to compare things. We call these relational expressions, and their job is totally different. Instead of spitting out a number, they just give you a simple, straightforward answer, true or false. And check this out, expressions can be nested inside other expressions. Before Python can even do the comparison here, it has to solve the little math problems on each side. First, it does 21 plus 13 to get 34. Then it does 40 minus 37 to get 3. Only then does it ask the final question, is 34 greater than or equal to 3? And yep, that's true. And last but not least, we have logical expressions. These are the real decision makers. They take those true or false answers we just saw and combine them to handle more complex situations. This is the magic behind how your if statements work and how your code decides which way to go. And they do it using these three little words, and, or, and not. And is strict. It needs both sides to be true. Or is more relaxed. It just needs one side to be true. And not just flips the value completely. These are super, super powerful. Okay, so we know what expressions are now. But we still haven't solved our mystery. Why 22? Well, get ready for the big aha moment. It turns out Python has a secret rulebook it follows every single time it sees more than one operator in an expression. And that rulebook has a name, operator precedence. If you remember PEMDAS or BODMAS from math class, this is exactly the same idea. It's a strict hierarchy that tells Python which operations are more important and which ones it has to do first. And this table right here, this explains everything. Take a look. Parentheses are king. They're at the very top. They always get done first. But look what's next. Down on levels 3 and 4, you can see it plain as day. Multiplication has a higher precedence, a higher priority than addition. All right, we've got the rulebook. We know the secret. Let's go back to that original problem and see if we can finally crack this case. Okay, here's the play-by-play. Python looks at 10 plus 3 times 4. It sees two operators, plus and times. It checks its rulebook and sees that multiplication has higher precedence. So it ignores the addition for a second and does 3 times 4 first. That gives it 12. Then, and only then, does it go back and do the addition, 10 plus 12. And that gives us 22. Mystery solved. But what if you actually wanted the answer to be 52? Well, the rulebook gives you a way to take back the power. Because as this quote says, parentheses have the highest priority. You can use them to force Python to do things in the exact order you want. And this side-by-side shows it perfectly. On the left, no parentheses, so Python follows its default rules and we get 22. But on the right, by wrapping 10 plus 3 in parentheses, we're telling Python, hey, do this part first. It has no choice, so it does 10 plus 3 to get 13, and then multiplies by 4. And there's our 52. You are officially in control. So look, this is way more than just a neat little math trick. Understanding this rulebook is absolutely essential if you want to write code that actually works the way you expect it to. Really, it all comes down to this. When you know the rules, you get predictability. Your code does what you think it's going to do. That makes it clearer to read, which means you'll have way fewer of those really subtle, hard-to-find bugs. It gives you the control you need to build complicated logic and actually trust that it's going to work. So I'll leave you with a little challenge. Now that you know about Python's secret rulebook, think about your own code. Are there any little calculations or logical checks hiding in there that might not be doing exactly what you think they are? Might be worth taking a second look. Thanks for joining me.